OK. So tangent. Now, hopefully you guys recognize this one's very similar to what we just did. But there's little differences. We're not going to write amplitude, right? No amplitude. But we have this 1/3. What is that 1/3 doing? Vertical compression, right? So we're still going to write that in. That still does affect the graph. So it's a vertical compression of 1/3. OK? So we're vertically compressing the graph of 1/3. Then we could also say, so it's vertical compression of a factor of 1/3. Let's see, we're going to have period. Now again, remember period is pi divided by the absolute value b. So b is what? 1, 2, or 1/2? It's right there, right? 1/2. Guys, x divided by 2 is the same thing as 1/2 x, right? So pi is divided by 1/2. Now, have we practiced this before? Yeah. Oh, man, I'm so glad we did that last chapter. Just multiply by the reciprocal, 2 pi. Now, I like this problem because this actually makes sense to me. Actually, when we did chapter 1, a lot of times I would think about trig functions. The period is pi. It just got moved to 2 pi. Do you see how the fraction makes it a horizontal stretch? Right? People always get it confused. They get the vertical. Oh, that's vertical stretch, vertical compression. But we always get the inside one mixed up. But again, if you think about it, here you're at pi halves. That changed my period from pi to 2 pi. Right? So when it's a fraction inside of the function, when you're multiplying by a fraction inside the function, that horizontally stretches the graph. Right? I'm not adding or subtracting inside the function. I'm not shifting anything up or down. So now we can just go to domain and range. But before we do that, let's do the range, because that's easy, because the graph is unbounded, right? But as far as the vertical asymptotes go, yes?
I'm confused as to why the period isn't 2 pi divided by the absolute b.
Because the graph doesn't repeat every 2 pi. Look, you did this. I did not do that. You did it. How long does it take? You can see that little curve is a distance of pi, not 2 pi. The distance from this asymptote to that asymptote, from negative pi halves to 0, is pi halves. The distance from 0 to pi halves is pi halves. Pi halves plus pi halves is pi. So the period, the distance it takes for this graph to repeat itself is pi.
Then how do you know when to use 2 pi and when to
Well,
use pi?
for 2 pi was sine and cosine. So in your notes, the period for sine and cosine was 2 pi divided by b. And in your notes, the period for tangent was pi divided by b. So just make sure you differentiate those two. Huh? No, we are. She just asked a question. So let's talk about so we got the range. The range is easy, though, right? But to understand the domain, we know that the domain is all real numbers except for where these vertical asymptotes occur, right? And what we talked about is the vertical asymptotes occur at x equals pi halves, right? Pi halves, and then plus every pi, right? And to represent like repeated adding pi infinite many times, we use the variable n. Now, that was for the initial period. That's with no transformations. When we looked on Desmos, guys, if we stretch or compress the graph, does that change where the asymptotes are? Let's look here. Here's the graph. If I shift this graph up or down, do those asymptotes change? No. If I stretch or compress, do those asymptotes change? No. If I move those graph left and right, do the asymptotes change? Yes. If you move, you're moving everything. If you stretch or compress, the asymptotes are going to change as well. So that means this is not my asymptote equation anymore. So what do you do? How do you find the new asymptotes? That's the asymptote equation for the initial period. So all you're going to do, vertical transformations don't impact the graph. But when you're falling asleep, inside transformations do impact the graph. So all you're going to do is set whatever's inside of your function, in this case x divided by 2, you're just going to set that equal to your asymptote equation. Then how do you solve for x? Multiply everything by 2. So x equals pi plus 2 pi n. And therefore, your domain is going to be all real numbers such that x cannot equal pi plus 2 pi n. Wow. I don't know, Miss McLogan. That's a lot to take in.